So welcome everyone. I think everyone is entering the room at the moment. Thank you very much for joining our event today. This event is brought to you by World Biogas Association community, which we call WBA Connect Plus. We've launched this community this summer, not too long ago, and we have around 450 people on our online platform. And we will be organizing events like this every month. We've run a webinar and a coffee chat in the summer, and this is our first event where Nick Primmer and David Harren and David Newman, our community champions, are present. For those who haven't noticed, haven't joined the community, please do so. This is what's coming up. On October 22nd, we have a roundtable. We will hear from our champions in North America and in Asia on the opportunities and what drives the markets, global opportunities versus local realities. And then on November 26th, we have another webinar talking about India, the markets in India. We have a speaker from EBRD. On December 9th, we'll wrap up the year with a presentation about the markets and drivers of the market in China. So if you'd like to join these online events, head out to our online platform. When you are on the online platform, please click on the events button right here, and you will see the events. So then click on the event, and then you will see the Zoom webinar. When you click on the Zoom webinar, that takes you to the registration page. That's how you register for our events, and then we will send you reminders, and this is a QR code. If you have any questions about the community and our mission, do not hesitate to ask me or Amber, who is on the call, and we will send you the link to the community platform into the chat. And now, without any further ado, please welcome the host of our meeting today, David Harren, who is the council member of British Compressed Gas Association and who is a strategist and expert in clean tech startups and strategy, and our community champion. David, over to you.
Thank you very much, Aya, and welcome everyone to today's event. As Aya said, yes, I've had a background now in biogas, quite short compared to people like David Newman, who's on the call, but basically, and probably even till Nick, so I didn't start in it till 2014, so only 11 years in the sector. But actually, I spend my time now doing consultancy and involved with trade associations. I was involved with setting up a whole set of biogas plants or gas biomethane plants and use operations for a French multinational. So lots of experience on producing and using gas, but really happy today to be welcoming Nick Primmer. Nick has also got a background in trade associations originally, but many, many years ago, and now he's actually looking after all of the policy requirements for Future Biogas. And I think it's going to be a fascinating talk to actually enlighten us around what Future Biogas have been doing around unsubsidized biomethane.
Cool, pleasure to be here. Shall I kick off with my presentation now then? Yep, let me just share my screen then. Just wait for that to... There we go. Hopefully everyone can see that. I'm assuming so. Give me a shout if anything goes wrong.
It is there, and I should have said, Nick, before we started, that basically there is a Q&A button at the bottom. So as we go through, if you could put your questions into the Q&A at the bottom, then basically we'll pick them up and I'll sort of direct some questions at the end of the meeting or presentation.
That's great. Yeah, thanks, David. And yeah, thanks for the introduction too. So yeah, I'm Nick Primmer. I'm the policy lead at Future Biogas. Been here for about 3.5 years, and before that I worked as a policy lead at ADBER and the WBA. So I have some background in the trade association too. So as David mentioned, I'm going to talk a bit today about the partnership of Future Biogas and AstraZeneca, the work we've been doing to decarbonise AstraZeneca's gas operations and the business model that underlines that deal. Hopefully, I'm going to sort of touch on a lot of different points, and hopefully that will stimulate a good discussion after the presentation. So to get into it, a bit about Future Biogas. Future Biogas is one of the UK's leading producers of biomethane. We develop, operate, own 13 biogas plants across the UK, primarily located in the eastern region of England, producing about 600 gigawatt hours of green gas per year, making us our contribution, it's about 10 to 15% of the total UK production of biomethane. And as part of that, we have started capturing the biogenic CO2 from the upgrading process, initially just from the one plant, but that's going to be rolled out across our entire portfolio and included in all of the developments of any future plants too. So at the moment, we're looking at 14,000 tonnes of biogenic CO2 captured per year, but that's going to substantially increase over the coming decade. And these plants are fueled primarily by rotational crops grown in partnership with local farmers. So across the UK, we work with about 400 each year to grow the feedstock for our green gas production. And in case you're unaware as well, AstraZeneca is one of the largest pharmaceutical companies in the world. It's an English and Swedish company with bases all around the world too. But our partnership is really a UK-based case study. So what we do is very much focused only on the UK operations of AstraZeneca. But a bit more about the background. There, in 2020, the CEO of AstraZeneca announced an incredibly ambitious net zero target, something that has really driven all of their strategic decisions in the last 6 years or 5-6 years, and has really changed how they operate and how they are decarbonising their process. And so that is the 98% reduction in scope 1 and 2 emissions by next year. So they are going to be completely net zero in the energy they consume. That's the oil, gas, electricity, is going to be 98% net zero by next year. And then on top of that, that's a 50% reduction in scope 3 emissions by 2030, that should say, by 2030. So they have an incredibly ambitious and rapid decarbonisation pathway. And this is for a major company that in the UK alone employs 10,000 employees and has an economic output of £8 billion per year. So it's something like it represents about 1%, or maybe even more than 1%, of the UK's entire GDP. So it's an absolutely huge company. And as this whole presentation is about, I'm going to be talking about that partnership where AstraZeneca signed a 15-year agreement to buy over 100 gigawatt hours of unsubsidized biomethane annually from Future Biogas. So this is a key aspect of that gas decarbonisation pathway and getting to that net zero target in time. So a bit more detail about Future Biogas. As I mentioned, we operate 13 plants across the UK, located in these green arrows, producing 600 gigawatt hours of biomethane per year. But crucially, we have a really ambitious plan to scale up production, build new plants, increase that capacity, and capture more CO2 as well. So over the next decade, we're looking at about 20 new plants, increasing production by 2.5 terawatt hours of biomethane per year, and capturing 500,000 tonnes of biogenic carbon dioxide each year for utilisation or storage. And this is how the schematic of each and every plant is looking like under the umbrella term of Project Carbon Harvest. So we take agricultural feedstocks. As I mentioned, these are the rotational crops grown by local farmers, typically within about 10-mile radius of a plant. And we work with them to reduce the emissions from agriculture. So these are rotational crops grown within a wider and diverse crop rotation, typically with a food-dominated crop rotation, and using the break crop within that rotation for biogas production. And then as part of that system, we're returning all of the digestate back to our farmers, so recycling the nutrients and replenishing the soil with organic carbon. And then from that, we're producing our unsubsidized biomethane for industrial off-takers and capturing the CO2 for utilization or storage. So each and every single plant, we're looking at increased soil carbon sequestration, so potentially about 4,000 tons of carbon sequestration in those local farms, avoiding 30,000 tons of CO2 from the displacement of fossil natural gas, and removing 20,000 tons of atmospheric CO2 if that biogenic CO2 is taken to geological storage. So a huge, huge carbon benefit. And that's why this Project Carbon Harvest is focusing on the carbon. It's no longer just about energy. It's a system which is all about carbon benefit and valorizing that carbon reduction and removals throughout the system. And just a bit more detail on that feedstock. So as I mentioned, these are rotational crops grown within a long and diverse crop rotation. And that diversity is absolutely fundamental to sustainable agriculture worldwide. You know, if you want to grow a sustainable food crop, you cannot just plant that same crop year in, year out. You will start to see falls in productivity and the increased reliance on chemical inputs to maintain that production. So if you want sustainable long-term production from farms, you need this diverse crop rotation. And within that, you need a variety of different crops. And here we are growing in the UK. It will be different for different regions around the world. There's not a one size model that fits all. In the UK, in the regions we're looking at maize, rye, barley, grasses as grown as the break crop within such a crop rotation. And when you do that sustainably and pull in other sustainable farming practices like the use of cover crops to protect your soil over winter, minimal tillage, so you're not overturning the soil each and every year, you're only doing it when absolutely necessary. These kind of techniques are ultimately improving the sustainability of production and will ultimately increase the production of food throughout the entire cycle. And the biogas crop forms a way a farmer can help diversify their production, both environmentally, but also economically, providing that, you know, secure off-taker for their production that's different to everything else. So you're sort of diversifying the business model of the farm. And as shown by research in both the UK and the EU, this rotational model for cropping represents one of the largest untapped feedstock potentials for biogas in the UK and Europe. So it's going to be absolutely fundamental that we realise the potential of these new feedstocks in realising the biomethane potential. And just as a bit of an example, this shows one of our sites in Lincolnshire. So a plant called Grange Farm, and on average, all of its feedstock is sourced about, well, just under 5 miles away from the plant. And you can see as through this animation, each year, different fields are being used to grow that feedstock, you know, representing the crop rotation over time. So we are supporting all of these local farmers diversify and decarbonize their production. So now if we look at AstraZeneca by comparison, you know, completely different industry being the pharmaceuticals. In the UK, they have 5 primary bases, as you can see on this map. But in their main operational factory is the one in Macclesfield, pictured here. This is the one that hires thousands of people and is a sort of their main production site in the UK. And this is where they came into, you know, how do you decarbonize such a huge operation and one that requires a huge amount of high temperature heat? So as you can imagine, if you're making pharmaceuticals and medicines, you need sterile environments. And to get that sterility, you need a lot of steam. So that presented one of their key energy challenges. They needed a lot of steam, and to produce steam, you needed a lot of high temperature heat. And how do you decarbonize that? What are the options available? So this is where they came to this process, this step-by-step process. They had that ambitious target. They knew they needed to decarbonize their energy by 2026. So then you look at the different options. You can electrify things, you can use different, you know, there's a variety of biofuels available. And they quickly came to the realization that doing a like-for-like replacement from fossil natural gas to biomethane is an incredibly expensive way to decarbonize. So what they started to do is say, well, what can we electrify easily? What can we reduce the total energy? What improvements to the efficiencies can we make? How do you improve the entire system? We're not just talking about production of steam. We are talking about energy use across every single aspect of AstraZeneca in the UK. And through that, took a few years in the making and significant investment. You know, they have electrified space heat. They've improved the efficiency of every single process. They've taken out a CHP, which produced on-site electricity and heat, and replaced that with a boiler, because if they need heat, the boiler can produce the heat, and the electricity they can get from wind and solar through PPAs. So they've gone through a huge sort of rethinking their entire energy system. And in it, they were left with about 100 gigawatt hours of what they called unavoidable gas demand, something that they needed it because it's the best and most cost-effective and practical solution. And for that is where we came in and offered biomethane. So the biomethane is cost-effective for those hardest to decarbonize sectors, those hardest to decarbonize energy uses. So they signed a long-term offtake agreement, and we built them a plant to inject biomethane into the grid for their use. And that is what the plant looks like. So this is More Bioenergy in Lincolnshire, and it opened this February. We had a fantastic launch party to sort of welcome ministers and AstraZeneca and various other, plenty of other people in the industry to sort of showcase the UK's first unsubsidized biomethane plant. So it's generating enough biomethane for AstraZeneca's UK operations, and at the same time we're capturing the CO2 from the upgrading process. And crucially, this unsubsidized aspect is really important to AstraZeneca too. I should focus this on too. So they knew they needed biomethane, and they knew they wanted to claim the carbon savings from its use, production and use. So to really do that, they wanted it to be unsubsidized. They valued the true additionality, that if they are fully funding the production of that green gas, they can claim full ownership of its carbon savings. This is a step away from models which rely on government subsidy, where the government subsidy is doing a lot of the heavy lifting in terms of the business model, and then corporates are claiming the carbon savings of the back end of that subsidy. So they wanted full ownership, so full additionality being delivered. So it's all about that best practice and sort of making sure everything is ironclad throughout their system and carbon reporting. And from Future Biogas's perspective, we have a whole pipeline of new plants in the works. I've got 7 here that are in active development, in planning or in pre-planning, with the ambition to significantly scale up the production of unsubsidized biomethane for other corporates to, follow in the footsteps of AstraZeneca. And they very much follow the same blueprint. So to look a bit more in detail about the business case of production and the role of subsidies and unsubsidized market, if we look at a conventional AD plant in the UK, what you're earning, what that economic model is really built on is you're producing gas, so you are able to sell the gas you produce based on the today's gas market. Same as fossil natural gas or biomethane, you are getting that gas price. And that gas price is being topped up heavily by a government subsidy. So in the UK, it's the Renewable Heat Incentive, the RHI, or the Green Gas Support Scheme. So that is a fixed rate feed-in tariff style support scheme that gives that additional subsidy for that, to recognise that this isn't just any gas, this is nice green gas to decarbonise the UK's gas grid. On top of that, you can get biomethane certificates. So that's a certificate to prove that this gas is green, and those certificates can be sold to corporate off-takers so that they can claim the use of the green gas being produced. And that's a conventional AD model in the UK. But then if you look at the Future Biogas's Project Carbon Harvest plants, and this is true for more bioenergy, you have your unsubsidized biomethane. So that is a bundled price that not only accounts for your gas production, but the fact that this is green gas and it incorporates your RGGO certificates, your renewable gas guarantees of origin. You know, it bundles it all together. So it is a biomethane product that isn't being split into energy and carbon. It's a combined product being sold to off-takers. And then on top of that, as I've been mentioning, we're capturing the biogenic CO2 from the upgrading process, and that CO2 I put here as greenhouse gas removals, because we're looking at sequestration opportunities to which we can then sell greenhouse gas removals to other corporates. We're also exploring utilization pathways like SAF or construction, food and drinks, all sorts of other products, and that combined income stream is really, you know, building the business model of these unsubsidized plants. I mean, if we look at this from a commercial perspective, so if we look at this from AstraZeneca's perspective, or well, anyone who needs green gas to decarbonize their gas products, so you've got the cost of gas, and of course, for many companies, you're looking at this and saying, well, yeah, it's cheaper for them to buy fossil gas and avoid biomethane. Biomethane is way more expensive than fossil natural gas, so they'll stick to that. So this is where it comes back to that need for high-level buy-in. You need the CEOs of these companies to say, we have an ambitious net zero target and we are doing everything we can to do it. So it's not good enough to say, oh, well, this is cheaper, because this isn't in line with the net zero ambition. So you need companies to want to go beyond what they are legally required to do ultimately. So this is very much driven by the voluntary market at the moment. But they've got the cost of gas, and on top of that, that's a volatile gas price, as we've seen by you know, various geopolitical situations like the Russian invasion of Ukraine and issues around sort of the Middle East as well. The cost of gas is highly volatile. So at sometimes, you know, when Russia invaded Ukraine, suddenly natural gas was more expensive than our unsubsidized biomethane. So it's protection from these markets. This unsubsidized biomethane is secured for 15 years. You know exactly how much you're going to be paying for that for 15 years. And you've got the cost of any carbon tax, so emissions trading schemes or literal carbon taxes on top of that. And how are they going to change over the next 10, 20 years? On top of that, the availability of biomethane. But we forecast there's going to be a huge amount of demand for biomethane in the next decade, and whether or not production can keep up with that demand. So, you know, there will be a reward for those moving into biomethane early. And if we look as well, it's where is this biomethane going to go? Where does it make economic sense to send it? This is a picture of the UK's current gas sector, you know, rounding up for nice numbers, but it's about 1,000 terawatt hours gets used each year in the UK. About a quarter of that is for power generation. Another quarter is exported to other countries. Another quarter is used to heat homes, so boilers, central heating, you know, going to domestic properties. And about a fifth of that is going to industrial gas use in transport. So that is something that we cannot decarbonize fully with biomethane. We need to tackle this using lots of different technologies. It's not just one size fits all once again. So if we look at what's unavoidable, where does it have to be gas? Where does it make most sense practically and economically for it to be gas? So we can massively reduce power generation by scaling up wind, solar, hydro, geothermal, all of these other technologies that generate electricity. We can reduce it, but there will be some level of power, gas-fired power generation as that base load capacity. It can offer a lot of flexible generation. There's a lot of benefits of having some level of gas-fired power generation. On the domestic side, there's plenty of properties that won't ever be suitable for you know, full electrification of their heat. There might be roles of hybrid gas systems, so you could have a heat pump, but it's complemented with some level of gas use. So it's a much more efficient process, but it still requires gas. But there'll also be plenty of properties that will still use gas because that is the practical solution. You know, if you've got a historic property that you don't want to tear out the central heating system and replace it with an electric equivalent. And similarly with industry and transport, there will be plenty of industrial processes that again require gas, whether that's high temperature heat, or perhaps it needs the molecular structure of gas in as part of the process. So there's still going to be a high level of gas demand in industrial processes. So that's where, you know, that's where we've got to change the mindset about these business models. We've got to reduce the gas as much as we can, and then use the valuable biomethane for those unavoidable gas uses. So we're using less, but spending more. So we're getting a better product, but using less of it. I also want to touch on the life cycle assessment. So a lot of the schemes in the UK, but also worldwide, you set simple sustainability criteria. And if you meet those criteria, you're considered sustainable and you've got a green gas certificate. What we've developed following this unsubsidized model is a life cycle assessment tool, an in-house ex-ante Excel-based LCA model to quantify the life cycle emissions from production to use of our green gas. And this is fundamental because it starts bringing value to carbon reductions, not just the fact that it's a green gas, is how green is it and how can we optimize the system throughout the plant, but the carbon reporting too. So this is what a typical life cycle assessment of our existing operations. So you can see a lot of the emissions, you know, you can drive, this is the production of fertilizers and the resultant nitrous oxide emissions from the fertilizer use. And this isn't just true for crops grown for AD, this will be true for a lot of arable crops grown for food and everything. So these are very common within the agricultural sector. And then on top of that, you've got fugitive emissions from the plant. So this is something that we as an industry need to be tackling and shining a spotlight on and really making sure that fugitive emissions are as low as possible. And that's why our target case, so these are the same columns, you can start reducing emissions throughout the entire system. And this is, you know, from the use of more organic biofertilizers and more bespoke nutrient management systems. You can reduce the emissions from fertilizer production and use, but also emissions throughout the entire supply chain to greatly reduce the carbon impact of biomethane production. And if we compare that to other types of energy, so if this is the carbon intensity of natural gas, and it varies depending on where you're sourcing it and how you're transporting it. You know, is it from the North Sea in the UK, or is it being produced in the US, liquefied and transported by boat to the UK? That will all impact the carbon intensity of the natural gas. Then you've got biomethane, and this is different sources based on different feedstocks and the quality of production, basically. And that's comparable to what some of biomethane's existing infrastructure are already delivering. But this is where, by moving to these unsubsidized plants with carbon capture and storage, we can really start to see reductions in the carbon intensity of production. So that's the base case I showed and the target. So these are deliverable, and this is what we are moving towards now, this target case of very low carbon intensities compared to natural gas. And if you combine that with CCS, you can start delivering carbon negative outcomes, and few technologies can truly deliver that. And then if you compare that with solar and wind, we're looking at carbon intensities comparable to these technologies that are widely considered to be the most sort of green and sustainable technologies. So this is incredibly impressive levels of carbon reduction or even removal. So I've kind of touched a bit on this, but just to re-emphasize that these approaches, our approach is supporting stakeholders throughout the entire supply chain. The farmers getting that long-term security and enabling them to decarbonize. We get a source of high quality feedstock, and we're getting that sort of business case security from both the farmers and the off-takers. The environment, is being improved. You know, we're reducing greenhouse gas emissions, improving biodiversity with the crop rotations, sequestering carbon within the soils. The UK benefits from enhanced energy and food security and the development of rural economies. And the customers are able to deliver immediate and scalable decarbonisation, something that hasn't been really available from other technologies. While delivering sort of lots of other wider benefits. And just to conclude as well, so this is what is holding back other companies from replicating what we've achieved with AstraZeneca. And it's really all three of these things. It's about how these greenhouse gas emission savings can be reported both on the compliance market, so emissions trading schemes, the voluntary market, often ruled by the Greenhouse Gas Protocol, but also traded between countries, and the union database is proving an issue in Europe. So, you know, we can produce the gas, we can inject it into a gas grid, companies want it, but what is the key barrier is the ability to connect production and use and have those carbon savings transferred robustly and securely and sustainably to those off-takers. And I'll leave it there, open to lots of questions. Thank you.
Thank you very much, Nick. That was excellent. And there are lots of questions, that's true. I'm trying to sort through some of those as well in terms of, so I'll try and get to as many of those as I can. Just to pick up on something, because you talked a lot about the partnership in there. Could you just really pick up on the additionality point? Because I know it's really important to AstraZeneca. And I think for those not familiar with the term, not sure it kind of completely was clear from that. So if you could just explain what additionality means.
Yeah, absolutely. So the definition of additionality is our real carbon savings being delivered by the deal? You know, is there actually a change in greenhouse gas emissions? So what AstraZeneca are demanding is what the solution, you know, what they are demanding is they want a real world reduction in greenhouse gas emissions as a result of this deal. It's not good enough that they will just claim it. They need to demonstrate that carbon emissions are actually being reduced. So that's the fundamental principle of additionality. And being an unsubsidized product, AstraZeneca are fully funding the biomethane production. And by being, you know, by fully funding it, they are therefore fully responsible for any carbon savings that come off the back of its use. So that's where they can truly report it. And just to sort of emphasize the point, by contrast, if there is a subsidized product where the government is paying for 80% of the, underlying 80% of the income for that biomethane production, is it fair to say that an end user who's using those certificates and claiming biomethane use, are they truly delivering those carbon savings? Because perhaps that biomethane would have been produced whether they bought the certificate or not. So are they actually leading to a change in emissions from that subsidized gas? You know, it's really a spectrum. It's not a yes or no answer, but AstraZeneca really wanted to make sure that they are fully responsible for the real world changes of carbon.
Great, thank you. And you talk a lot about partnerships in here, and they have farming partnerships I'll come to, and sort of, but a partnership with AstraZeneca. There's a question in there saying, do you see this as being kind of your model or a potential model going forwards, really, where it's that larger industry use partnering with biomethane production to kind of do that in this subsidized approach? Do you see that as being more and more the way to go forward?
Absolutely, yeah. I think, these kind of, we are always looking for new sort of industry off-takers that can provide that have that high level of demand for green gas and wanting to get into these long-term partnerships for it so that they can, decarbonize their production. And then in a similar way with the farmers, they're seeking long-term partnerships with people who will buy their feedstock, buy their production, so that they know for the next 10 years, we're working with Future Biogas, and we know exactly how much we're going to earn from our feedstock per year from the proportion of their land that is used to grow feedstock.
Just to clarify, this is AstraZeneca fully funding it. This is not UK government coming in to support them. This is totally their funding, which kind of ticks on the box. In terms of then, people are asking about the feedstock choice in terms of why you went down the crop route rather than wider bio-waste or bio-waste in general, and also, basically your plants are they capable of coping with the bio-waste or manures, etc.?
Yeah, so we chose to go down the crop route because, well, for a number of reasons. Firstly, it is the largest untapped resource of feedstock in the UK. Farmers, if anyone who is familiar with British politics at the moment, farmers are under such economic pressure. They are being squeezed from all angles to make their farming business profitable. So they're looking for new opportunities to diversify their income and sort of build their business case resilience. But they're also under pressure to decarbonize. They're facing sky-high fertilizer costs, and that's only going to increase as the carbon tax for imported fertilizers comes in the next few years. And so they're looking for opportunities to find local sources of nutrients, things that can improve their soil health, opportunities to, if they want to diversify their crop rotation, they need markets to grow crops for these new markets. So there is a huge demand from British farmers for, to drive the uptake of these more sustainable practices. And this is an option that gives them this option to those farmers. So that's why we're focusing on that. And that's aligns with the Future Biogas in-house expertise. We have a farming team and feedstock team. We know the farming sector incredibly well. So it sort of lines up with our strengths. And on the other side as well, why not waste? In theory, our plants could process waste. Anaerobic digestion can break down any organic material. We don't, or at least our new plants won't process waste, partly because of regulatory, we'd need to get additional permits to process wastes, but we're not going down that route. But also there's question marks around the sustainability of wastes. There's a long running assumption that just because it's waste, it's therefore sustainable. And absolutely, for the wastes, unavoidable wastes should all be recycled through AD. It is the most sustainable way of recycling wastes. But we don't want a system, or we're wary of any system that starts incentivizing the production of waste because the biogas is valuable. So, I think that's something the sustainability criteria needs to address and regulatory frameworks. But it's the short answer is because what we specialize in, and we're seeing a huge opportunity in the UK to scale up with rotational crops.
And I'm going to pull in my fellow host, David Newman, who's got a couple of questions for you.
Oh, thanks, Nick. That was a great presentation. I guess you all know one of the questions without even me asking it. But the first question, you talk about long-term take-off arrangements with the farmers. And that gives them long-term security, but does it give you long-term security in terms of crop price? I mean, crop prices will presumably vary and be very volatile according to market conditions. And does your long-term takeoff agreement include a long-term price agreement? That's the first question. The second question is, what are you going to do with all that digestate?
Yeah, so yes, the long-term partnerships with the farmers, the feedstock price is adjusted for inflation, but also adjusted for the cost of inputs. So it's very much an open book deal. We will pay them more if their inputs cost more. It will fluctuate, but still sort of based up, you still get the certainty. So the risk is on Future Biogas, not on the farmers, because as everyone knows, the feedstock is everything to AD. We need to keep the farms on site, particularly those that are, working well with us. The digestate was the second part of the question. All of that digestate is being returned to the farmers that are growing for us. And quite frankly, they would take more if they could. It's done proportionally. So if you do 50% of the plant's feedstock requirements, you'll get 50% of the digestate. But yeah, they would take more if they could, typically, because they're recognizing the value of the nutrients. You know, it's cost effective. They're not paying for the digestate. It's baked into this partnership. They get it back as part of the deal. You know, they're seeing the value in the organic chemistry going back to soil. Yeah, it's sort of a mutually beneficial deal between us and the farmers.
Thank you very much.
And just to follow up on that, in terms of, I think there's some questions coming through in the fave where people are seeing this as energy crop. And I think it's worthwhile, Nick, if you just explain how this is actually rotational crop as part of that farming cycle and part of the carbon cycle, rather than actually being an energy crop.
Yeah, that's right. So the term energy crop came from a regulatory framework where everything was channeled through the amount of energy you could produce. So a lot of the early subsidies, all it cared about was how much energy can be produced, and therefore you work backwards and you grow the crop that produces the most energy, and you can grow it over and over again. And it's not necessarily a sustainable way of farming, but it works based on the regulatory framework. That's not what we're doing. What we're doing is this rotational crop. So the farmer, as part of that long-term partnership, they're signing up to sustainable farming practices as well. So they're agreeing that you're not just growing the same crop on the same bit of land over and over again and really sort of exploiting that natural resource. Instead, you're incorporating it into this long and diverse rotation. We're typically talking about 5-6 year rotations. So an individual field will grow 5 different crops or 4 different crops on 4 different years. And then in the 5th year, it will grow a crop for biogas production. And then that cycle will start again. And that approach is really fundamental to the sustainable agriculture of all 5 of those crops, all 5 of those different markets. You couldn't grow any single one of them over and over and over again on the same bit of land. So it's beneficial to the entire rotation.
Yeah, and I'm trying to pick up questions. There's lots of questions all over the place. I'm trying to kind of keep them into themes here. So I'm picking up different aspects from that. So there's questions around the CO2, and kind of large parts of the themes are trying to understand acceptability to standard markets. Obviously, you planned as well for routes in terms of longer term into the North Sea, etc., but also trying to understand where you were on certainty on those routes when you made the investment decision, and just generally how that process works in terms of, if you could talk through that CO2 journey, where you are now, where it may be, and how you see that evolving.
Yeah, sure. I think one thing that's really clear is the demand for bio-CO2 is set to skyrocket over the next couple of decades. All of the targets and all of the strategies, from the aviation sector to heavy industries to all sorts, they will need or atmospheric derived CO2 in some way or another. So we felt in some way assured that there is this sort of long-term future that if we're going to capture it, it will be valuable. So when we installed it in Gonna Be More, the initial thing is current the bio-CO2 that's currently being captured is being sent to the food and drinks market. So that's also an existing utilization market that has grown strength in recent years and has sort of given the economic protection for that investment. That we know that we could sell it onto the existing market, and in the UK that's about 600,000 tons of CO2 utilization per year, and we can feed into that, particularly as various historic sources of CO2 for that market have been closing over the last 5-10 years. So there was positive market direction in that, but then we're talking to multiple additional pathways. So SAF production. You know, the UK government has introduced a mandate for sustainable aviation fuel, SAF, and that requires a source of atmospheric derived CO2 or carbon for that molecule. And where are you going to get that? There's very limited sources of commercial scale atmospheric derived CO2. And AD is ultimately one of the most efficient ways of capturing that CO2. So we're talking to off-takers there. We also know that, the whole net zero, net implies, it's the result of some emissions, but some removals. So we know we're going to need some removals, and we're talking to lots of different big off-takers who, as part of their own decarbonisation strategy, they need some permanent, high-quality greenhouse gas removals. So again, there are the developments around the UK for sequestering that carbon dioxide, and we're talking to them. We're looking at ways in which we can feed that in and generating these removals credits that could be sold on to corporate off-takers. So there's a lot going on, and in some of these markets, it's brand new, but we know the positive direction. We know some of the initial market signals have indicated that this biogenic carbon is highly valuable. So that gives us the confidence to keep building CCS onto our plants, both our existing plants, but also every new plant we're going to be developing.
And just to clarify, you're basically taking that CO2 and purifying it to a food grade standard and then monitoring. So basically, which to be fair would be the same standard as if it went to the North Sea, pretty much, basically.
Yeah, exactly. All of our plants have membrane upgraders, and particularly with the CO2 liquefaction after the membrane separation, you're getting incredibly pure food grade CO2. But also, as a sort of additional benefit, you're getting an extra amount of biomethane back into the system. So you're actually improving your biomethane production, reducing your fugitive emissions, and also capturing very high quality pure biogenic CO2.
And that comes through to one of the questions, then, just going back into the whole concept of that model you've talked about in your life cycle assessment. How are you accounting for fugitive emissions within that, and how are you kind of measuring and tracking that as part of the process?
Yeah, this is something we've spent a lot of time and effort in the last few years. So we have recently bought a series of cameras to detect fugitive emissions, which we're using for leak detection across the entire plant, every single section. We're tying that in with a pretty robust LDAR strategy. That's a leak detection and repair strategy. So we've got to be on top of all of these, even the smallest leak of methane over an entire year can add up to significant emissions. So really getting on top of any leaks, no matter how small they are, detecting and repairing. Part of our new plant design, so our new plants have learned the lessons of the existing ones. Things like solid concrete roofs, single piece concrete roof, reducing the amount of joints, and joints are always where leaks happen. So if you have a single piece of roof, you're immediately lowering the likelihood of leaks to occur. And that's, just one example of reducing future emissions through the whole system. And then on top of that, we get a third-party consultant to come around and also monitor and assess and audit methane slipped, and those figures directly feed into the life cycle analysis.
And I think wrapping a couple of questions in there, one of which is really, does the GHG removals you get and therefore impact into your biomethane value? Is there a kind of linkage between the two? And I think people also thinking in terms of they're used to seeing affected biomethane tickets, so RGGOs, etc. But can you explain how that how your model works slightly differently than that in terms of how that sits?
Yeah, sure. So that's right. So under this approach, the biomethane and the bio-CO2 are separate products, and they're very much treated as separate products. So when you leave the AD plant, the upstream emissions are effectively proportioned between these two products based on their economic value. So biomethane will get some of the upstream emissions, and bio-CO2 will get the others. Those emissions will be attributed to the biomethane's carbon intensity, and that's what it will be reported against by anyone using that biomethane. And then the bio-CO2, depending on its use, will also have a carbon intensity based on emissions derived from its production. If you're going to a removals credit, this is all sort of brand new, and regs are currently still in development. But the idea is, if you were to send that CO2 to geological storage, the first amount of credits, those removals credits you would get, the first amount would immediately offset any emissions incurred in its production and capture, and then you'd be able to sell those extra credits onto corporate off-takers for them to claim the carbon benefit. Some people do talk about carbon negative energy, and we are a bit wary of blurring these two products. So what you could do is you could send the CO2 to geological storage and then put that carbon negativity onto your biomethane value to get carbon negative biomethane. And that is a way of doing it. And but that could be valid. My only my personal concern about that kind of approach is, firstly, it will be very expensive, because you'd have to then sell your biomethane for an astronomical value, because it's also got to fund the sequestration of the CO2. But on top of that, I'd be conscious of any system where you could produce biomethane, which may not be that sustainable. It doesn't deliver that much carbon benefit. But if you put on a massive carbon negative credit on top of that, suddenly it becomes sustainable. And that's not really a system we want to promote. We want to make sure that both products are fully sustainable and create their own markets, basically.
Yeah, and I think it's probably worthwhile. So both longer term, you basically see value change from the biomethane, the CO2, and the digester.
Exactly. Yeah, that's right.
I think a couple of last questions are sort of in there, and apologies for those I've missed the questions. They just keep flooding in, basically, which is great to see. And fairly unusual for me. Normally, I don't get overwhelmed completely with questions, but I've tried to cover the main themes here. Do you see that, that route to store by 2035? People ask about RED III, which obviously doesn't apply in the UK, but route to store, do you see that being ready by 2035? Do you see that becoming possible? How do you see that wider evolution happening?
Yeah, it's a big question. I think by 2035, I should really hope that it's up and running. So we had Northern Lights in Norway, the geological storage facility in Norway. That is now live and actively storing CO2. So, that's kind of a commercial scale project that's being proven today. The UK facilities, there are the two Track 1 government-backed facilities as HyNet on the west coast and Endurance on the east coast. And I think the official launch date is 2028, but I think everyone in the industry knows it's going to be more like 2030. But these are major systems that are going to be storing carbon before long. And on top of that, there are countless wells which are more or less depleted of natural gas and are ready to store CO2. That if you can justify, if you've got the scalability, if you can provide enough biogenic CO2, and if you can demonstrate a big enough demand for the certificates, which is definitely also coming, you could start developing completely unsubsidized, ungovernment-backed, or unsupported, I should say, sequestration projects all around the UK. And I think that's coming too. So it's so hard to say a date, but yeah, I think we could reasonably get to geological storage within the next 10 years, for sure.
And I think last point that was in there was, you've got a great partnership with the partners you work with, and it's all quite intense, but we're seeing more and more extreme weather events in the UK. And how does that put that into threat in terms of the modelling that you're or the risk in terms of that economic modelling you've got?
Yeah, so the risk of productivity, the agricultural productivity, soil health is everything. You can build your soil, your farming resilience by improving soil health. And the model intrinsically supports improved soil health through the digestate use, through the improved soil management practices like minimum tillage, use of organic fertilizer, cover crops over winter. these are fundamental to soil health. And so we're seeing an improved resilience to climate change on farm. And then to additionally protect future biogas from climate change based impacts on climate, is we are not relying on one single crop type. So while maize accounts for about 70% of our feedstock today, we are looking at new crops, new options, diversifying that feedstock composition, so that if maize was to have a bad year, we have other feedstock types, other crop types that will respond differently to those same climate conditions and build the operational resilience too. And there's a multitude of crops that are being explored and being expanded, and that's an important aspect of the agricultural approach too.
Thank you very much, Nick. We've kind of run out of time. Apologies. I've tried very much to take lots of the themes of the questions, and rather than sit reading question by question in terms of there, to try and cover as much of the topic. I'm not sure that's made everybody happy with that process, but look forward to thank you for those questions, and I'll hand back to Aya now in terms of the next steps.
Wow, I'm feeling overwhelmed as well. This is a fantastic presentation, Nick, David Newman, David Harrod. Thank you very much. It's been, we learned a lot of information, very useful and very inspiring story. We're hoping to see more and more of this, not only in the UK, but everywhere. And for those who shared your questions and you asked me questions in the chat, please go to the WBA Connect Plus online platform. This is where you will be able to talk to Nick, to everyone, and ask your questions. This is where we will share the recording of the presentation later on. This is where you can sign up for future events and be together and impact the world around us. Thank you very much, everyone, once again, and see you in October.
Thank you.
Thank you,
Cheers.
everyone.
Thank you. Bye.